Hope this has been helpful for you so far. I mean, this has been preparing for this boot camp has been a learning experience for me. Uh, Sometimes you perform pen tests and you really don't know that area well enough, and so this has kind of helped me learn at the same time. Because earlier in my career with the web app pen testing and mobile pen testing, it was kind of difficult starting out. And then I took some training. I actually took the INE web app pen testing course and mobile pen testing course and got a little more education on it. And it made the job a little easier. So sometimes with education, not even the offensive side, just understanding, like for instance, understanding Azure, just understanding some other technologies can make you understand this area more. So as I've mentioned, if you don't have experience with Azure, then I'd recommend going back and taking some of the Azure content that we have. There's like some cloud basics or intro to cloud that Tracy does. So if you want to really get good in this area, then I would go back, focus on that. That being said, too, if you're interested in cloud, this is one of the areas that I really recommend people learn, because there's a lot of jobs in offensive security, but it seems like people are having a harder time finding cloud talent, people that understand cloud from a blue team perspective, digital forensics, incident response, as well as offensive security. So those are really good areas to work in. And from what I've seen, pen tester wise, I've seen that people are making, anywhere from $20,000 to $40,000 more a year doing cloud pen testing opposed to just general pen testing. And part of that comes with, the lack of talent. When there's not as many people with that skill, then you're kind of, you're going to have to pay more to get the talent, to encourage someone to leave. Someone's working for, even maybe a cloud provider, they're working for Azure or AWS, and you're going to try to get them over your team. Those companies pay well, so you're going to have to pay a premium to get them over there. So that kind of, drives prices up, just kind of like thinking about homes nowadays, especially in our area. Home prices, I mean, houses are getting sold up quick. It's hard for people to find homes. They're not able to produce them quick enough. And that's kind of like talent. If there's not enough talent, then people have to pay a premium to get that talent. So today we're going to discuss on-premise technologies to access Azure. So some of these exploits or techniques are going to be golden SAML, pass the PRT on-prem AD attacks to gain privileged access to Azure. So the golden SAML attack. So this vector enables an attacker to create a golden SAML, which is basically a forged SAML authentication object, and authenticate across every service that uses SAML 2.0 protocol as a single sign-on mechanism. So this is taken from this CyberArk article down here below, and we're going to take a look at that a little bit closer here in just a minute. And this is not an Azure-only attack vector. So this is used across AWS and other platforms. Golden SAML was used in the SolarWinds breach. So that just kind of gives you some idea of where all it's used. So we're going to go ahead and take a look at this a little deeper. First, I think we're going to start with kind of explaining, let's see here. Yeah, so we're going to take a look at that. And so the primary refresh token, according to Microsoft here, since this is more what although it can be used in other areas, we're focused on mainly concerned with the Microsoft perspective. So what is a primary refresh token? So we're going to take a look at that, because we need to understand what that is before we can exploit it or assess the security. So a primary refresh token, I'm sorry, we actually, let's back up. Wrong place here. So, okay. Okay, so golden SAML attack. CyberArk has a really good article on that, which we'll review here. Let's see. All right. And this blog post, they introduce a new attack vector discovered by CyberArk. Let's see when this is. Okay, this is from 2017. So this is something that existed, and some instances of breach and exploits that can be used, or sometimes because people aren't patching their systems or updating their configurations to prevent against it. And sometimes there's the attackers figure out how to, and sometimes security researchers will find out how to attack these mechanisms on different systems, and so exploits come out later. So maybe this come out, whenever this come out, then they even listed when this came out as it affected Azure. So this is one of the things to show you with your exploitations. A lot of times configuration vulnerabilities, forgetting to patch, and those type of things will leave you open and vulnerable to attacks. So here, let's see, in this blog, we introduce a new attack vector discovered. So it's not new anymore. It's 4 years old now, almost. It's dubbed the Golden SAML attack. It's basically a forged SAML authentication object and authenticate across every service that it uses SAML 2.0 protocol as a single sign-on mechanism. So you see a lot of stuff using single sign-on. People are using Google for single sign-on. People are actually using like Microsoft for single sign-on. So in this Golden SAML attack, attackers gain access to any application that supports SAML authentication. So here they mention Azure, AWS, vSphere from VMware, etc., with any privilege they desire, and can be any user on the target application, even one that is non-existent in the application in some cases. So they released a new tool on that. So CyberArk does come out with some really cool tools. I have a friend from the community that actually works for CyberArk. He was one of their pre-sales engineers, and now he's over in the research department now. So we're going to go down here and get a little more further into. So in a time when more and more enterprise infrastructures is ported to the cloud, the Active Directory is no longer the highest authority for authentication and authorizing users. AD can now be part of something bigger, a federation. So you use federated services to access different applications and resources. And so this can be used for other applications, as we were kind of looking at some of the architecture of Azure AD, how you can use this to authenticate to other people's applications and stuff. And so the good thing about single sign-on, it's a way for, if securely implemented, then sometimes it's a way to make things more secure. Some of the application vulnerabilities that we used to see was these developers would go ahead and just try to create their own authentication mechanisms, and therefore there was some vulnerabilities and weaknesses in it. So they were able to get exploited. So as time's gone on, people are going to more single sign-on solutions using existing authentication mechanisms instead of trying to roll their own. So talking about a federation, an attacker will no longer suffice in dominating the domain controller. So yeah, and also too, from these attacks, you can also take advantage of this, then you can actually get access to the on-prem AD. So the Golden SAML name may remind you of another notorious attack known as Golden Ticket, which is introduced by Benjamin Delpy, who is the famous creator of the tool Mimikatz. This is a great tool. We kind of mentioned this in here. So it's a way you can dump clear text credentials as well as some other password attacks. It's a really, really good tool. A lot of endpoint protections are starting to see that. So if you run that, you need to obfuscate the code to try to get it to work without detection. And there's also like the invoke Mimikatz tool, which is a PowerShell version that works pretty well. So the name resemblance is intended since the attack nature is rather similar. Golden SAML introduces a federation that the advantages that the Golden Ticket offer in Kerberos environment or gaining any type of access. So SAML explained. So for those of you who aren't familiar with SAML 2.0 protocol, we're going to take a minute to look at the details on that. So the SAML protocol, or security assertion markup language, is an open standard for exchanging authentication and authorization data between parties. in particular between an identity provider and service provider, beyond what's named suggests, SAML is the following: an XML-based markup language, a set of XML-based protocol messages, a set of protocol message bindings, a set of profiles utilizing all the above. So the interesting thing when you look at SAML and some of these other different technologies we use nowadays, I remember back like in the back in the early 2000s, when there was a lot of these, it escapes me the name of the product, but Microsoft had like a middleware product that let different services and applications communicate with each other. And so as these protocols like SAML come along, it made things integrate a little more easier. You didn't have to install this other application and set up another server just to get this stuff to work. So SAML is a way to enhance this with single sign-on. And so that quotes from Wikipedia: the single most important use case that SAML addresses is web browsers and single sign-on. So we see a lot of single sign-on out there nowadays. A lot of times there's different applications that will allow you to use a third party like Microsoft or Google to access using your existing identity. So this is where that really comes in handy. So this kind of shows a demonstration of the identity provider, the client, and the service provider. So you got your service provider here, say this is Microsoft, then you can go to this identity provider to access this service provider. So, the service provider doesn't always have to be the identity provider. So we can kind of see how this works. So login request finds the identity provider, generates a SAML auth request, redirects user with IDP with SAML request, authenticates the user, and generates a SAML token and SAML response. So then returns the SAML response with the service provider, redirects to the service provider with SAML response. So verifies the SAML response signature encryption source as a trusted IDP, and then logs user in. So then the user has access. So first the user tries to access the application known as, so we just kind of covered this. So SAML report response structure. So talking about a golden SAML attack, the part that interests us the most is number 3. So we see for number 3, redirects the SAML response. Since this is the part we're going to replicate as an attacker performing this kind of attack, to be able to perform this correctly, let's have a look at the request sent in this part of the SAML response. The SAML response object is what the IDP sends to the service provider, and this is actually the data that makes the SPI identity and authenticate the user, similar to the golden ticket generated by a KDC or Kerberos domain controller. The general structure of SAML response and SAML 2.0 is as follows. So written in purple, the dynamic parameters of the structure. So we can kind of see how this response is built. And so you see the XML code within there. So depending on the specific IDP implementation, the response assertion may either signed or encrypted by the private key of the IDP. This way the service provider can verify the SAML response. Similar to the golden ticket attack, if we have the key that signs the object which holds the user's identity and permissions, just like the KRBTGT for golden ticket and token signing private key for SAML, we then forge an authentication object, a TGT or SAML response, and impersonate any user to gain authorized access to the service provider. Roger Grimes defined a golden ticket attack back in 2004 not as a Kerberos ticket forging attack, but as a Kerberos key distribution center forging attack. Likewise, a golden SAML attack can be defined as an IDP forging attack. In this attack, an attacker can control every aspect of the SAML response like the username, permission set, the validity period, and more. In addition, golden SAMLs have the following advantages. They can be generated from practically anywhere. You don't even need to be part of the domain federation of any part of the environment you're dealing with. They're effective even with two-factor is enabled. The token signing private key is not renewed automatically. Changing a user's password won't affect the generated SAML. So AWS plus ADFS plus golden SAML is the case study. So let's say you're an attacker, you have compromised your target's domain, and now you're trying to figure out how to continue to the final goal. So one option now is available. You're forcing using a golden SAML to turn further to compromise your asset agents. Active Directory Federation of Services is Microsoft standards-based domain service that allows the secure sharing of identity information between trust and business federation. It is basically a service in a domain that provides domain user identities to other service providers within a federation. So this kind of goes back to one of my stories that I shared about using Clear Trust by RSA back in the day. Okay, thanks for sharing that, Don. So yeah, kind of going back to this story with Clear Trust, this is kind of what Clear Trust used to do with authentication, providing federated services to access other applications. Back then, you had your middleware that you could use to communicate between applications. If you needed to authenticate external entities, business partners, or consumers, then you had to use something like this Clear Trust. But using things like SAML and the single sign-on has really helped in that area a lot. So here's a list of requirements for a golden SAML attack. Token signing private key, IDP public certificate, IDP name, role name to assume, domain username, role session name. Okay, this is more specific to AWS, but you kind of get the picture here, kind of the gist of a golden SAML attack. So there's another good resource here. It's a golden SAML advisory. And so this is kind of more related to mentions the SolarWinds software supply chain attack. And so this slide or this site here shows more how, the other article gave you a good idea of what golden SAML was, but it was more tied to Active Directory. More towards AWS. And so our focus here is Azure. So this kind of shows you how that's performed. So in the process to explain golden SAML attack, we first short description. So user attempts to access desired services, AWS. So they're mentioning AWS again here, but this is the demo here shows how it's using ADFS and more of so service redirects to user to ADFS authentication. User authenticates with ADFS according to domain policy, multi-factor authentication, etc. ADFS returns a signed SAML response to the user machine. User presents desired service with SAML response and receives access. So we kind of see how that works in a Microsoft world. So we see ADFS. So the way that, it's kind of, this is the federation service. And so we see the client machine. This is the service provider. So they're using ADFS to authenticate. So that's what the legitimate process looks like. So for the golden SAML attack, you got attacker, let's go back here. So attacker accesses ADFS server and extracts private keys and certificate. User attempts to access desired services. Service is redirected to ADFS for authentication. So we see here they're stealing the private keys and certificate, and then user attempts to access desired services. So over here is trying to access this. Service redirects attacker to ADFS. So it's being redirected to ADFS. And so the attacker machine has these forged credentials. So it then signs the forged SAML response with stolen key and then authorizes the access. So this is kind of, in a sense, when you think of some of your other attacks, kind of a man-in-the-middle attack, this is kind of got the similarities there. You're intercepting this traffic, you're forging your identity, and then providing access. So as can be seen in this attack process, once ADFS private key and certificates are compromised, attackers will gain persistence, access to all relevant services, critical data, infrastructure, and can now be compromised without any additional access to the victim's environment. This is powerful access and will persist until the existing ADFS private key is invalidated or replaced, a difficult process requiring altering or terminating connectivity to all the federated systems. So if this goes undetected, then they're probably going to maintain access for a while. Then you can create other persistence there too. So, so it goes into details on detecting and hunting for golden SAML attacks. So anyone that's in SOC or incident response, this might be interesting to read up on. And maybe in Jason's boot camp, he may discuss that. So I'll put that up there. So there's another good article, just a good reference from MITRE. So if you're not familiar with the MITRE attack framework, it's a really good resource. And so this kind of tells you about forged web credentials, SAML tokens. So this is more of a general overview of it, but this is basically what you're doing there, and this is involved in golden SAML. So we can see the references here, 2017 for golden SAML. So this is a really good site, not only for red team, it's good for defenders too. I think one of their latest offerings is MITRE Attack Shield, and that kind of gets more into the defense side, but just understanding the different types of attacks, the different types of TTPs, this is a good one. And this even shows that APT 29 used compromised SAML signing certificates. Seeing the date on this, so that was 2008 to summer 2000, okay, in April. So so this was actually the APT involved in SolarWinds. So if you go through there and look at the APT, it's kind of interesting getting to understand the different attacks and the different groups. It's pretty interesting stuff. Also good information to have when you're doing like purple team engagements. So this next slide here, we are covering past the primary refresh token. So a primary refresh token, or PRT, is a key artifact of Azure AD authentication on Windows 10, iOS, and Android devices. It is a JSON or JWT, which is JSON Web Token, specifically issued to Microsoft first-party token brokers to enable single sign-on. So more abuse to single sign-on across the application used on those devices. So first, and this was actually taken from this Microsoft document. So really good stuff on Microsoft on their products. There's a lot of good documentation there. So what is a primary refresh token? And a primary refresh token, or PRT, is a key artifact of Azure. So yeah, we kind of covered that So key terminology and components, the following Windows components play a key role in requesting and using a PRT. So cloud provider or cloud AP is the modern authentication provider for Windows sign-in and verify as user login to Windows 10 devices. It provides a plugin framework that identity providers can build on enable authentication to Windows using identity provider credentials. And so Web Account Manager, or WAM, is the default token broker for Windows 10 devices. It also provides a plugin framework for identity providers to build on to enable single sign-on for their applications relying on that identity provider. Azure AD Cloud AP plugin is a specific plugin built on Cloud AP framework that verifies user credentials with Azure AD during Windows sign-in. Azure AD WAM plugin is an AD-specific plugin built on the WAM framework that enables single sign-on to applications that rely on Azure AD for authentication. DSReg, an Azure AD-specific component of Windows 10 that handles the device registration process for all the device states. And TPM, or Trusted Platform Module, is a hardware component built into devices that provides hardware-based security functions and user device secrets. Some more details, you can actually search more on that on the Trusted Platform Module. So really interesting to see how these technologies and stuff have evolved. I mean, it's interesting the way attacker tools evolve and they make things more automated, but it gets more difficult as time goes on because, starting out as a pen tester in 2012, things weren't as complicated. You were more focused on Active Directory, just the internal hosts and stuff. But with the way, with Azure, all these different single sign-on solutions and stuff, how more complicated made things. If you really do things right, you can make it more secure. But if you're not careful, there's so much complexity there that you could miss things. So George says, in one of the hack the boxes, I learned how to brute force JWT tokens. That's great. You see a lot of stuff related to the web app pen testing. I've seen some other online offerings that show how to abuse JWT tokens. So that's where when you really think about pen testing and before people really didn't think much about learning some of the web piece of things, understanding some web app pen testing can really make your life easy as a pen tester, because there's some cases that you're going to run into some of these technologies that understanding the different technologies are going to do better, opposed to just focusing on just network and the host itself, focusing on some of these applications and other technologies. So that gave us an idea of what a PRT is from Microsoft. And so we're going to go over here and look at this. And this is a really good site. If you don't, just about anything related to Azure AD and Azure is listed on this site. So let's see, according to Microsoft documentation, okay, so we kind of covered that it's a key artifact. AD, to simplify it, a token is used to identify users and devices. The issued token is valid for 14 days. So what can we do with the PRT, with the plain text token? Nothing. We need a session key, which is issued the same time than the PRT. Windows 10 computers must be Azure AD joined or hybrid joined to be able to create the PRT. According to documentation, during the registration, DSReg component of Windows 10 device creates two key pairs, the device key and the transport key. The private keys are preferably stored on a TPM. So we went over that in like the Microsoft article, the device that that holds these keys. The device key is then used to identify devices, whereas transport key is used to decrypt the session. The session key is used as a proof of possession, POP, and also protected by TPM. So you think of something you have when it comes to multi-factor authentication. Using existing PRTs. So browser core.exe, all the keys well protected. How to use them. The easiest way is to let Microsoft Windows components do all the work for you. So I showed the Microsoft Edge and Chrome through extensions uses browser.exe to generate a signed PRT token. The generated token can be used either as a cookie, HTTP request header, both name as x-ms refresh token credential, and Azure Active Directory internals. I'm using Dirk Jan's approach to send the request to standard in on browser core.exe and read the results of the standard out. I've added the PRT token parameter to get the ADD int access token for service. So functions you can pass to the PRT tokens to get access. So here they are showing an example of using this. So that first thing, you're getting the PRT token, get access token for AD. So you're getting, so you see here that you're requesting those tokens. The nicest thing here is that if PRT was issued with multi-factor, the resulting access token also has the MFA claim. So a way to get around multi-factor authentication. Yeah, let's go. Matteo, let's go through here and see what they have as far as that. Maybe they'll have something related to that. So the Mimikatz way, so Mimikatz release 2.2, Azure past the PRT has everything needed to extract the PRT session. So below I'm using the virtual machine without TPM. Mimikatz may behave differently on a computer with TPM. First step is to launch Mimikatz and get the debug privilege. So here we're at launch Mimikatz and get the debug privilege. So now we dump the cloud AP stuff. So here we're doing run Mimikatz and then doing the cloud AP. So if you hadn't played around with Mimikatz, then that's a really good tool to use. Not only can you use it on Azure, you can use it on standard Windows environments, legacy Active Directory and the clients. So the output contains a lot of users, but we're only interested in those having Azure AD as their domain. So here we see the test user, and they're part of the Azure AD domain. And so we see the SID. And so we see the DAPI key, the get UID, and here's the PRT there. So we can kind of scroll over and see that key. So see that key. You see the display name and all the information on that PRT key. So and then they're going to just kind of clean up PRT to see the following. So this shows how it shows up. So you got this nice format when you go through. It makes a little more sense of what you've got there on that key. So we see the version, the primary SID, the display name, test user, and identity. So you actually see the email address that this person is using. Password change URL, pretty interesting that you can actually see where the server is to change the password in. And so PRT receive time. And so you get the expiration time, session import time. So that kind of gives you a more beautified or cleaned up look at that. Next, we decode key value from proof possession key to get the session key. We continue by elevating to NT system authority. So right here, they ran the elevate within Mimikatz. And so we see that it's elevated to NT system authority. And so NT system authority locally is the highest level access that you can get to a machine. So it's basically kind of like the equivalent to root on a Linux or Windows or Unix box. So David Klein said, in general, would you say Firefox is inherently a bit more secure? Yeah, I would say it's in my opinion, it is. I kind of choose it over like Chrome, but yeah, I think it's a little more secure and it's a little more privacy aware. But there's like the Brave browser. If you hadn't checked that one out, that one's really, really more secure focused. You can import a lot of your bookmarks and settings from Chrome, and it's supposed to be faster. And you can actually connect to Tor with Brave, with the Brave browser. And so it's really privacy minded. If you're really wanting to, really want a privacy minded browser, then using something like, if you're using like Parrot OS, the browser in there has a lot of privacy plugins. And so that's another option too, as well. That's more secure. So Matteo, for golden ticket seems easy once you got the key, but how to get the ADFS servers and steal the key? Could you please give us an overview of that? Let me do a little more research into that. Because like I said, So we have the PRT and the session key, clear key from above. We can generate a PRT token using the credentials. So you see this, Mimikatz, add padding. This is generating a new token with the knots. At this point in time, well, this is back in September 2020, Microsoft changed authentication flow for PRT tokens to require knots. With this session key PRT, a new PRT can be created as long as the PRT is valid. So as demonstrated, we can also use the session key and PRT to get Azure AD P2P certificate. That certificate in turn can be used to access other computers joined to the Azure tenant. Continue previous examples, we can get the certificate with ADD internals. So here they're running a command to get the certificate. And here's the output. The generated certificate can be used with Azure AD joined machine to access other Azure AD joined machines. So how to create a token. It was quite easy to dump required information using Mimikatz, but how is the PRT token actually created? The answer is by creating a JWT and signing it with a key that's derived from the context of the session. So the context is 64, base 64 encoded random byte array of 24 bytes, and it's added to the JWT header. Note all slashes must be escaped with a backslash. So see here, they got slash and everything escaped with the backslash there. The body of the JWT contains its primary always true IET, Unix time, in seconds, and refresh token PRT. Here we see the refresh token. Both header and body are separately encoded, byte 64, and the padding is removed. They're concatenated with a period as a separator. The result turns into a byte array UTF-8 encoded and signed. So the key used to sign JWT is derived from the session and context as explained by Dirk Jan. He used bcrypt key derivation to derive the key. The key derivation is using NIST SP 800-108 KDF key derivation function, which already knew from export ADFS internal ADFS signing certificate. So the signature is 256-bit. Deriving the key was a walk in the park. Okay. A little pandemic humor there. So the key is derived calculating the HMAC SHA 256 value from the following byte array using the session secret as. So the parameters used are explained below. So we see the different parameters there. The final byte array, how it was calculated. After calculating the final array, byte array, the resulting byte array can be used to sign the JWT. The base 64 encoded signature, padding removed, is appended to the end of the header as long as using the period as a separator, creating your own PRT. We go into details on how to create your own PRT. Yeah, well, you could use Tor browser, yeah, but just kind of mentioning that you could, Tor is actually built into Brave. Good morning, Jason. So they claim to be 3 times faster than Chrome. I'll put this link up there if you're interested in the Brave browser. But this, some of your other browsers, some might be a little more secure, but then something like Brave, they're trying to be more security and privacy minded. So here this goes through showing how to create your own PRT. And so PRT and multi-factor authentication claims. The PRT has multi-factor claim, and the PRT acquired is using some form of multi-factor. Based on the author's research, the information is stored into the Active Directory Azure AD device object. Of course, it can be edited after the device is registered. So in summary, the PRT tokens can easily be created with Windows components for the current user, but the 2 main ingredients, the session key and the PRT itself, much harder to get access to with Mimikatz. However, these can be exported, at least from the machine without TPM. We also learn how to create your own devices, register them to Azure AD, and access 2 devices. With those certificates, we're able to create a new PRT with the corresponding session token. After generating the session key and PRT, we're able to create our own PRT tokens with them and access tokens to Azure AD Office 365. Also, we're able to create P2P Azure device and user certificates, which can be used to laterally access other Azure AD joined computers on the same tenant. By joining our own devices to Azure AD and acquiring PRT tokens for that device, it is possible to emulate corporate computers and bypass certain conditional access policies based on the device state. So yesterday we mentioned using a user agent to bypass conditional access. This is another way that can be done. So Matteo says, Tor is very slow usually, plus I don't know if it's really true, but some security researchers think what you use Tor machines can be on a special list for NSA. Not much telling. It wouldn't surprise me. And it's kind of an additional resource for the PRT attack. So this one kind of discusses lateral movement with the golden tickets, also like over past the hash and some other, so it's a little extended reading there. So another good resource. Yeah, as far as the recorded Zoom sessions, those will be posted up on the bootcamp section of INE. And then also, this course was built off of a course that was recently created. So the full course, or the actual course that I use to prepare for this boot camp, will also be available. Yeah, and the good thing is too with so even if you go through this boot camp, I would still recommend going through that course when it comes out, because to learn something, sometimes you need to go through it. So just like maybe some of the other courses you may be taking here through INE, once you go through it like a second time, it clicks. And so I definitely recommend going back through that. And also, if you're not really familiar with Azure, then take some of the Azure training to be a little more familiar with it. So this one's a little less wordy example of that last article on past the hash, the PRT, I mean. But the link that we showed here, this site really has a lot of good stuff based on Active Directory, because this is where the Active Directory kill chain information came from. So when Slavi was doing his research for this course, he got a lot of good information from this website. Also, like another really good resource is adsecurity.org. It's Sean Metcalf's site, and it's got like a lot of good information. I'll pop that link up there so you have it. But this contains a lot of good information. I was doing a Active Directory pen test last year for a previous employer, and AD Security was a really good place to do research on pen testing Active Directory. It wasn't so much, it wasn't Azure Active Directory, it was just testing, legacy Active Directory. But that's good to know, because you may be in some environments that are hybrid and have some on-prem. So on-prem may help you get into Azure and vice versa. So yeah, I think that, David, I think there'll be like a distinct, a certain section that's only accessible by premium members. So I'd share the link up, though. I'll go ahead and display the site I was referring to. This AD Security. So there's some different presentations on there. There's specific information on Mimikatz. That's a really good tool to learn how to use. Jason probably you'll have to attend Jason's boot camp. He could probably tell you some Mimikatz stories. I know he's like not a fan of cobalt strikes. So that some of the things that you may hear, some of the stories you may hear in his boot camp,